Okay, uh, welcome to the session. Today's concept is higher order differential equations with constant coefficients. In this topic, in this concept, we are going to find the general solutions. In the general solutions, in the today's session, we are going to discuss about how to find the complementary functions. Okay, the topic name is higher order linear differential equation linear differential equations linear differential equations. Okay, this is today's topic name. Okay, let me choose black color pen. Okay. Higher order linear differential equations. First, what do you mean by differential equation? And after that, what is the meaning of linear differential equation method? And what is the higher order of linear differential equations? Okay, generally we know the equation, mathematical equation. Generally we know mathematical equation, that is the algebraic equations. Suppose the equation is, if I'm writing like this, x square plus 2x plus 1 equals to 0. This is called algebraic equation or else polynomial equations, and other standard form. Other name is quadratic equation. The first name is algebraic equation or else polynomial equation and or else the standard name is quadratic equation. Why it is called quadratic equation? Quadratic means second. So here there are only single variable x, and x is there. The highest degree of x is 2, so that this is called algebraic equation of degree 2, or polynomial equation of degree 2, or quadratic equation is second degree algebraic equation or second degree polynomial equation. So only this is algebraic equation involving only single variable x and x. If the differential equation means an equation which involving the differentials, also called differential equation. For example, the same equation, if I'm writing like this, x square plus 2x plus 1 equals to 0 is called algebraic equation. Suppose the complete equation, suppose if it is involving the derivative like this, dy by dx. Now in this complete equation, there is one derivative is involved. The derivative is called dy by dx. So now here the derivative is involved, so that this equation is called now differential equation. That means an equation which involving the derivatives is called differential equation. And clearly you can observe that in this differential equation there are two variables are there. The two variables are x and y. So they are naming as their names as like this. Here always in the derivative dy by dx, means this is a derivative of y, right? Derivative of y with respect to x, means here the differentiation we are taking the differentiation of y with respect to x. So here the variable x is called independent variable because you are differentiating this, so that this variable is called independent variable, and the variable y is called dependent variable. This is called dependent variable. dependent variable. And here clearly you can observe that this dy by dx is called the first order derivative. So here the differential equation is involving first order derivative. So the name of this differential equation is also called as first order differential equation. Differential equation. If it is equation involving the second order or third order, so that the equations are called second order differential equation or else third order differential equations simply. So the general form or some example for second order differential equation is, okay, for that just I am adding new board number 2, right? Okay, board number 3. Next, here I am taking the board number color, I am taking as white color, sorry, green color board, and for that I am choosing the white color pen. Okay, now here the example for the second order differential equation is, for example, like this: d square y by dx square and plus 2 into dy by dx and equal to some function. That function you can take as e to the power of 2x. So in the complete equation, how many derivatives are there? There are two derivatives are there. One is called dy by dx. Okay, one is dy by dx and one more is d square y by dx square. So that, okay. So there are two derivatives are there. One is dy by dx and one more is d square y by dx square. So here it is clearly known that this is a first order derivative, right? It is the first order derivative. It is a second order derivative. The highest order is second order. So that this equation is called second order differential equation. Simply writing as differential equation. So higher order is second order derivative. So that this is called second order differential equation. If the equation is involving the third order, like this: d cube y by dx cube and plus 3 into d square y by dx square and plus 2 into y equals to some function is sin x. So in this derivative, the highest order derivative is, in this differential equation, the highest order derivative is d cube y by dx cube. So this d cube y by dx cube is third order derivative. Third order derivative, or we may call as differential. So that the name of this differential equation is third order differential equation. Differential equation. The same way, now we are going to discuss the higher order differential equation. What the today's concept is, right? Okay. 1 minute. Okay. Today's concept is a higher order differential equation. This is our today's concept. Higher order linear differential equations. So the general form of the higher order linear differential equation is, like, you can write yes, this. An equation of the form, like d power n y by dx power of n plus something into d power of n minus 1 y by dx power of n minus 1 plus a2 into d power of n minus 2 y by dx power of n minus 2 plus so on dash 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 plus finally an into y equals to some function of x. This is called the general form of nth order linear differential equation. So here what is the highest order? D power n y by dx power of n is the highest order derivative. So complete this differential equation. This differential equation, that is okay. In this differential equation, the highest order is nth order derivative. So the name of this equation is called. So an equation of the form is called as nth order linear differential equation, and with coefficients are here a1, a2, a3, a4, so on as an, with a1 comma a2 comma a3 comma so on as an are constant coefficients. Because here a1, a2, a3, an, all these are what? Constants. So the coefficients are constant, so that this is called an nth order linear differential equation with constant coefficients. And complete the right side is equals to some right side function here, f of x. That f of x is the function, or the function involving the variable x. So here right side function f of x is a continuous function, of independent variable x. Okay, this is a general form of the nth order linear differential equation with constant coefficients. Previously we discussed that we are giving some examples for third order. This is a third order differential equation. Here 3 and 2 are the constants, so this is called third order linear differential equation with constant coefficients 3 and 2. These are the two constants, and is equals to right side. The function is sin x. Sin x is a continuous function. And similarly, the above example, that is a second order differential equation with the constant coefficients. Here 2, only one coefficient is a constant coefficient. So this is called second order differential equation with constant coefficients. Next, these are all equations. In generally, we know in mathematics, the equations means we need to find solutions. Here we need to find the solutions which are satisfy the given equations. For example, what do you mean by solutions? So here, what is solution? For example, in mathematics, you can take any equation. For example, here I am taking one equation like x square plus 3x plus 4 equals to 0. You already know that this is called algebraic equation or quadratic equation. So this is a quadratic equation. So what is the purpose of this equation? What is our intention? What is our aim? To find the solution. To find the solution means finding the unknown value. What is the unknown value here? That is called x. So that we need to find x values. So already in elementary level we know how to solve this type of equations. On solving this equation means how do you solve this equation? For example, like x square plus 3x plus 2, we can factorizing this equation. What will get? X plus 1 into x plus, okay, 1 minute. You can use quadratic equation form like this. Minus 3 plus or minus square root of b square means 3 square minus 4 into a into c, 4ac, this is into, by 2 into a, 2 into a means 1. So if you are simplifying this square root, minus 3 plus or minus square root of 3 square means 9 minus here 4 into c values 4, right? So 4 into 4, 60. 60 equals to, by 2 into, take the example, next page. Okay, this is I'm cancelling here, this here I'm cancelling. Okay, so here already you know how to solve this equation. That means yes, you are finding the values of x. So the same way, just adding the new word, you can take color as black. Okay. Okay, once again I will take one more example here because to make you understand. Okay, for example, the equation I am taking is x square plus 4x plus 3. This is a very good example to make you understand what is solution. For example, here we can simplifying this. That is minus 4 plus or minus square root of 4 square minus 4 into 1 into 6. Sorry, 4 into 1 into 3 by 2 into 1. This is by using the quadratic equation. What is the general form of the quadratic equation? Ax square plus bx plus c is the quadratic general form of the quadratic equation. The solution of the quadratic form is, solution of this quadratic equation is minus b plus or minus square root of b square minus 4ac by 2a. Okay, so same way we are writing like this and simplifying this equation. Minus 4 plus or minus square root of 16 minus 9 by 16 minus 12, 16 minus 12 by 2, and this equals to minus 4 plus or minus square root of 16 minus 2 means 12 means 4, square root of 4 means 2 by 2. Next, simplifying this, minus 4 plus 2 by 2 or minus 4 minus 2 by 2, because there is plus or minus, so one time we are taking plus, one time we are taking minus. So this equals to minus 4 plus 2 means minus 2, minus 2 by 2 means minus 1, or here minus 4 minus 2 means minus 6, minus 6 by 2 means minus 3. So how many roots you are getting here? The x values are minus 1 comma minus 3. These are the solutions, and let check out this. So what are the x values here? Minus 1 comma minus 3. So these are called solutions. Solution means these are satisfied the given equation. What is the given equation once again here? There is x square minus x square plus 4x plus 3. Substitute the values of x, what we are getting. For example, x is equal to minus 1 here, right? X is equal to minus 1. Substitute here x is equal to minus 1. Okay, put x is equal to minus 1. Then minus 1 whole square plus 4 into minus 1 plus 3. This is equals to minus 1 whole square means 1. This 1 into minus 4 minus 4. So minus 4 plus 3. So 1 plus 3 means 4. 4 minus 4, 0. So minus 1 satisfies the given equation. So that minus 1 is called solution. Means the solution which satisfies our given equation. In the same way, in our differential equations also, we need to find the solution. We need to find the solution. But here the solutions are not the numbers, because differential equation involving two type of variables. That is, one is x variable, one more is y variable. One is x variable and one more is y variable. Just we now discuss that the x variable is called independent variable. X variable is independent variable here. This is x is an independent variable and y is a dependent variable. So here we need to find the relation between x and y. That is our required solution. Once again, here the solution means we need to find the relation between independent and dependent variables which satisfies our given differential equation. Right? Next, to find the solution here, there are some methods. Those methods we are going to solve. Okay. Next, go back to next board. So this is a general nth order linear differential equation. So for this nth order linear differential equation, now we are going to find the solution. We are going to find the solution. Solution means the relation between independent and dependent variables. Independent and dependent variables. Right? Okay, let us discuss how to find solutions. Okay, before going to discuss, here we need to discuss about the types of this nth order differential equations. There are two types of nth order differential equations. Okay, just add in the new board, choosing as color is okay, just different color. Okay, there are two types of equations. Let us discuss once again. Okay, first of all, we write again nth order differential equation, that is d power n y by dx power n plus a1 into d power of n1 n minus 1 y by dx power of n minus 1 plus a2 into d power of n minus 2 y by dx power of n minus 2 plus a3 into d power of n minus 3 y by dx power of n minus 3 plus our continuation plus an into y is equals to function f of x. So this is our nth order linear differential equation with constant coefficients a0, a1, a2, a3, so on as an. These are all coefficients. And here clearly you can observe that in the right side function, this function is a function of the variable x, independent variable x. And in application orientation, this is also called input function. Input function. So based on this, we are dividing into two type of differential equation. For example, if it is a function f of x is identical to 0. Okay, take out this equation number 1. Okay, if it is a function f of x is equals to 0, then the differential equation 1 is called as homogeneous, here I am adding homogeneous once again, nth order homogeneous linear differential equation. Okay, with constant coefficients. Next, if f of x may not be 0, there is some function f of x is cannot be given. Then one is called as nth order non-homogeneous linear differential equation. Linear differential equation. Okay. Okay. First of all, let us discuss what are the solutions of homogeneous linear differential equation, and after that discuss the solutions of non-homogeneous linear differential equations. Okay, once again, coming back. Okay, so before discussing the solutions, we need to discuss operator form and symbolic form. First one is operator form. Operator form and symbolic form. Symbolic form of 1. Okay. Here operator and symbolic form means just we are writing in terms of operators. That is, here let us take the derivative. dy by dx is the first order derivative. So what is the differential operator here? Okay, what do you mean by this? Differentiating y with respect to x variable. So the differential operator here is dy by dx is the operator. That dy by dx is the differential operator. Differential operator. Okay, first order differential operator. So that, and this differential operator simply is denoted by capital D. Capital D or d by dx, both the meaning are same. So clearly it is, I am writing as d is dy by dx. Instead of writing dy by dx, just simply I will write operator dy. And the same way is the second derivative, second order derivative. D square y by dx square I am writing as in operator form is d square y. And the same way d cube y by dx cube I am writing as d cube, capital D cube y. And so on, the generally nth order derivative. So that the nth order derivative d power n y by dx power n. This I am writing as capital D power n y. So writing in terms of capital D is the differential operator forms. So that what the first equation here? The first equation is this, d power n y by dx power n. So if you are writing the operator form, what you will get here? Okay, just I'm adding the new board. Okay, the board color I am taking as only white color. Okay, and let us check once again. So here d power n y by dx power n. Just I am writing as an operator form like capital D power n. Capital D power n plus a1 into d power n minus 1 y by dx power n minus 1. This I am writing as operator form a1 into d power of n minus 1 y plus next one is a2 into d power of n minus 2 y plus so on plus an into y equals to f of x. Next, these are writing in terms of operators, and also you can write simply y, and y. All y's are taken common and outside. That is, then you get d power n plus a1 into d power of n minus 1 plus a2 into d power of n minus 2 plus so on dash plus an into y equals to f of x. Next, we are all writing us in terms of capital D, means operator form. This also may call as operator form because writing in terms of only capital D's. This is called as operator form. Operator form of one. Next, in the next step, we are writing here. Next, d power n plus a1 into d power of n minus 1 plus a2 into d power of n minus 2 plus a3 into d power of n minus 3 plus so on and so to an. All these are in an algebraic expression in capital D, right? Like this: x power n plus a1 into x power of n minus 1 plus a2 into x power of n minus 2 plus so on, like this an. So this is an algebraic expression in terms of x variable. Here a1, a2, a3, so on, all these are constants. So the same way, this is also the relation. This is also is called an algebraic expression in terms of d variable. So the generally algebraic expressions are denoted like this: f of d into variable y equals what? F of x. So on comparing here, what is the f of d? Here f of d equals to d power n plus a1 into d power of n minus 1 plus a2 into d power of n minus 2 plus so on dash plus an is an algebraic expression in capital D. So if you're writing like this, is called symbolic form. Symbolic form of 1. Okay. So in the symbolic form, note. Already we discussed the types. Note number 1. If right side function f of x is identical to 0, then one is called as nth order homogeneous linear differential equation. Okay. Number 2, if f of x is not equals to 0, then and one is called as nth order non-homogeneous linear differential equation. Right? Okay. Next, let us go for discussing the solutions. Okay. For that, adding the new board, taking the green color board. For that, choosing the white color pen. Okay. Next, finding solutions. Here, two type of solutions are there. So the two type of solutions are, one is called CF. This simply is CF. Also, complementary function. And PI is particular integral. Okay, let us discuss. So already if we know the differential equation, the general form of what? This is a general form of nth order linear differential equation. Right? Nth order linear differential equation. So the general solution of this equation, and one more thing, for this equation we writing symbolic form is the symbolic form is like this is our symbolic form, right? And this is our operator form. This is our operator form. Okay. Now onwards, instead of taking complete nth order differential equation, simply I will take only symbolic form. This is symbolic form of nth order differential equation. So that here I will take the equation as, so what is general form, symbolic form of nth order differential equation? That is f of d into y equals to f of x. So already we know if the function f of x is nothing, if this is 0, then we call the differential equation is called homogeneous differential equation. If it is not 0, then the equation is called non-homogeneous differential equation. So the general solution of this type of nth order linear differential equations are given by like y equals to complementary function plus particular integral. Okay, this is the general solution. Is the general solution. General solution of y. Next, we need to find how to find complementary function and how to find particular integrals. Okay. Next, small note, small idea. If it is the function f of x is equals to 0, we no need to find particular integral. Just finding the complementary function is enough. Once again, general solution of y. Once again, if the function f of x is equals to 0, we no need to find particular integral. Just we need to find the complementary function is sufficient. Right. Next, first of all, how to find the complementary function? Okay, how to find complementary function? Let us discuss how to find complementary functions. Working procedure. Working procedure to find complementary functions. To find complementary functions. Okay. First, rewrite the given differential equation in symbolic form. In symbolic form. What is symbolic form? F of d into y equals to f of x. This is a symbolic form. After writing this equation, symbolic form, first take the function, that is take f of d. Here what is the f of d? F of d equals to our function of our algebraic expressions d power n into a1 into d power of n minus 1 plus a2 into d power of n minus 2 plus so on dash an. This is what is a algebraic expression. Algebraic expression. Algebraic expression in D. And what is of degree? Of degree, highest degree is n. And next, let us take the auxiliary equation from this algebraic expression. Let the auxiliary equation. Auxiliary equation as f of m equals 0. This implies instead of d, we're just writing m. Then m power of n plus a1 into m power of n minus 1 plus a2 into m power of n minus 2 plus so on dash plus an is equals to, because we are taking the auxiliary equation is balanced equals 0. Okay, so we are taking equals 0. Take out this is number. So what is the number 2? Is an algebraic equation, right? Okay, is an algebraic equation in F of degree F. So basically we know if the degree of nth order, or sorry, if the second order algebraic equation, for the second order algebraic equation, how many solutions are there? There are 2 solutions. If the third order algebraic equation, there are 3 solutions. If it is the fourth order algebraic equation, 4 solutions. If it is the nth order algebraic equation, sorry, nth degree algebraic equation, n solutions are there. So this is an algebraic equation in M of degree n. So that if you are solving this equation 2, okay, solving equation 2, we get how many roots? N roots. N roots. But then there arise 2 cases. Why? Because the 2 cases means there may be real numbers. Okay, the roots may be real numbers, roots may be complex numbers. So in case 1, 2 cases. The case 1 is the roots may be real numbers. And case 2 is the roots may be complex numbers. Okay, first of all, let us discuss about the case 1. For that, just adding a new board. Let us choosing the black color board. Okay, let us discuss case 1. In case 1, we are going to discuss real roots. Roots are real numbers. Okay, how many real roots we will get here? What we discuss? How many roots you will get? You will get n roots, because what the algebraic equation of degree? Or the algebraic equation of degree n. Degree n, so that will get n roots. If degree 2, then we'll get 2 roots only. Okay, we will discuss by taking some examples later. Okay, here let how many roots you are taking here? N roots. So let us take one is m1 comma m2 comma m3 comma so on dash mn are real roots. And also all are distinct. So therefore, how can you write CF for this respective roots? So therefore, CF can be writing as like this: C1 into e to the power of m1 into x plus C2 into e to the power of m2 into x plus C3 into e to the power of m3 into x plus so on that is Cn into e to the power of mn x. Okay, taking some example for this. Let's take some example. Example. Solve the differential equation. Solve the differential equation. Solve the differential equation. For example, here I am taking the second order only. So d square y by dx square plus 4 into dy by dx plus 3 equals to 0. So what we are taking here? Equals to 0. If you are taking equals to 0 in the right side function is, there is no input function. That means f of x is equals to 0. So what is the name of this equation? The differential equation name is homogeneous. Right? Nth order homogeneous linear differential equation. Right? Okay. Okay. So what is our working procedure? Here I am writing the solution. The solution. First write a given differential equation. Given differential equation is d square y by dx square plus 4 into dy by dx plus 3 equals to 0. Take out this equation. So what is our working procedure here? Go. So working procedure to find CFS. Rewrite the given differential equation. Rewrite the given differential equation in symbolic form. That is f of d into y equals to f of x. But here f of x is our function is 0. Okay. So write in the form of f of d into y equals to 0. So here I am going to write in symbolic form. Okay. Okay. So already if we know the operators, the second order derivative, so that the writing the second order derivative like this, d square into y plus 4 into this is a first order derivative writing as only dy plus here 3 into y, take 3 into y and 3 into y equals to 0. And from all the terms y taking common, you get d square plus 4 into d plus 3 into y equals to 0. So the given differential equation is writing in form of, this is what? Operator form. Right? This is the operator form. Next, this is taking us an expression like f of d into y equals to 0. So on comparing, what the f of d here? Your f of d equals to d square plus 4d plus 3. Go back. So first, here taking f of d is what? D power n. This is nth order. But our equation is second order. It is an algebraic equation in d of degree n. But what is our example here? Now this is an algebraic expression in variable d of degree 2. Right? Highest degree is 2. So what is the next step here? Next step, take the auxiliary equation. This is the next step. Take the auxiliary equation as f of m equals 0. So here I am going to take in the next word. Okay. Writing the auxiliary equation. Writing the auxiliary equation. That is f of m equals to 0. This implies that is m square plus 4 into m plus 3 equals to 0. Right. So this is what is a quadratic equation. So what are the roots? If you are solving by using the quadratic method, you will get the roots as m equals to -1, comma minus. So how many roots you are getting here? Two roots. So the two roots are real numbers. Real numbers as well as both are distinct and distinct numbers. Okay. So the two roots. So by comparing to our problem here, in generally what we said n roots. In generally what we said n roots. We are m1, m2, m3, m4, so on, mn are how many real roots? Real roots and distinct. But here our problem contains only two roots. Two roots are both different. Okay, first root, how can you write? Like this. C1 into e to the power of m1 into x plus second root C2 into e to the power of m2x plus if it is third root like this, if it is fourth root like this, if nth root like this. Okay, this is the way you need to write complementary function. So in our example, in our problem, there are only two roots. The first root is -1, second root is -8. So therefore, the complementary function we are writing as CF equals to C1 into e to the power of -1 into x plus C2 into e to the power of -3 into x. This is our required complementary function. Okay, this is the required complementary function. And also called general solution. Is the required general solution. What is the why required general solution is? There you no need to find a particular integral, because in the differential equation in the right side what we have here? 0. So if it is 0, no need to find a pi value. Okay. So this is a way to find complementary function. Okay, let us discuss one more example for this. For that, adding the blackboard and choosing white color board and taking the blue color pen. Okay, example we are taking here is solve the differential equation is that we are taking d square y by dx square plus, okay, we are taking plus next minus 5 into dy by dx plus 6 into y equals 0. This is a given differential equation. Next, let us start the solution here. First, take the given differential equation. Given differential equation is d square y by dx square minus 5 into dy by dx plus 6 into y equals 0. Next, just writing the operator form here. Capital D square y by dx square writing as an operator form like capital D square into y minus 5 into capital dy plus 6 into y equals 0, and this equals to y taking common, you will get d square minus 5d plus 6 into y equals to 0. So this operator form, and writing as a symbol form is f of d into y equals to 0. I am comparing here what the f of d. Here f of d equals to d square minus 5d plus 6. And immediately next step you can take auxiliary equations. The auxiliary equation you can write as f of m equals to 0. This implies m square minus 5 into m plus 6 equals to 0. This implies next m equals to how much? Solve the equation by using the quadratic equation. Now our time is still 5 minutes is there. Okay, within 5 minutes we can complete the problem, so that I'm accepting the alert. Next, within 5 minutes we're going to start the class. So on solving this equation, I think you'll get 2 comma 3 as a roots. Okay, these are the real and distinct. Real and distinct. So for the complementary function here you can write that c1 into first root e power 2x plus c2 into second root e power 3x. Or you may write the order like this also, no problem. c1 into e power 3x plus c2 into e power 2x. You may write any one of the order. Both are right answers. Both are right answer. This also right answer, this also right answer. So this complementary function is the required solution. This is just what we discussed. We only find a complementary function, the required solution. Okay, this is what we are finding is only complementary function. Only one case is over. Next case is real numbers and repeated real numbers. Here only we are discussing only distinct real numbers. In the next session we will discuss repeated and also complex numbers. That we'll discuss in the next session. Okay. And in this demo class, in the next the tomorrow session, we are going to discuss on the topic Laplace transforms, definitions and small basic formulas we'll discuss. Next, to register the online courses, just go to www.bijmathIQ.com. Next, here I will enter here www.bijmathIQ.com. Okay. This is our website. In my website, you can go and register. If you require the live classes, please go and register here, or else you can contact us on the contact number is 9490875895, or else you may email us. The email address is same way, bijmathiq@gmail.com. Next, I am signing off. Thank you.